Alright, this is my second podcast, and it's going to be on partially about Neil Degrassi Tyson and some other things related to physics. So, Neil Degrassi Tyson once attacked Bill Riley because he said that nothing can explain the tides, therefore God did it, or something like that. And not that I'm agreeing with him, but I want to point out that inventing a hidden medium, Einstein's space-time medium, isn't any better of an explanation because it's still a hidden form of causation. And it is simply just pushing the question back. You can easily see how inventing a hidden being to pull and push the tides is simply pushing the question back, because you can just ask why the hidden being. But you can do the same thing with a hidden space-time medium. Second problem is that there's no point in inventing a hidden form of causation, like where the medium is bent by a planet. There's no sense in doing that when physicists already do not understand ordinary causation. And obviously, it's in the image of ordinary causation, because that's all we can imagine. And it creates the fact that what I mean by they don't understand ordinary causation is that it's discontinuous. And that was Einstein's initial motivation for inventing the hidden space-time medium, was that he didn't like Newton's action at a distance. That is, he didn't like almost like a teleportation of influence. Like, how can two objects being separated influence each other? Because we have the everyday experience of contact. The problem is that this isn't even contact. There's no such thing as contact, because pure continuity is not conceivable. So when you invent a hidden medium, all you're doing, you can play it out in your mind's eye. You can see that any filling of a gap will leave a smaller gap. And if you try to fill that gap by zooming in, you're just going to leave a smaller gap, and a smaller gap, and a smaller gap. So you can never get rid of gappiness. You can never get rid of action at a distance. And that presents a problem for Einstein, because it makes it so that you need sort of a rationale for why energy is transferred from one object to the next, but without trying to fill it. It's the first sort of rationale I might give for a pre-existential disposition, meaning it's not anywhere. This explanation is not part of existence. People have a little trouble when I say stuff like that. I like to point out that explanation can't be part of existence, because then it would be circular, because we're looking for an explanation for existence. So you can't, at best, you're just pushing the question back. That's all you're doing. I'm not sure how much I want to go into that right now, because people are going to have problems with that idea until I can show you what I even mean by these pre-existential dispositions. So I just want to hold off on that. Another problem with Degrassi is somebody asked him where why all the planets orbit in the same direction, and he came up with it. He was saying that it's because the original accretion disk, or the original cloud, was spinning in one direction. And the first problem with that is it doesn't explain how the spin gets translated into orbital energy. There's an explanation needed there, and also why there's a cloud that's spinning in the first place, and why it's spinning in one way rather than another way. So you can't have asymmetry for free. You can't have structure popping out of a homogeneous situation. You're not going to get things moving asymmetrically in a loop. I want to touch on this asymmetry thing. The human mind only asks for explanations when a situation is asymmetrical. We say this way rather than any other way, and we go why, or any way rather than not at all, and we ask why. But when a situation is symmetrical, we don't ask for an explanation. One example of what I call a symmetrical asymmetry is ordinary exchange itself. The fact that it's symmetrical or symmetrically asymmetrical, because if you have like a big mass, a big ball and a small ball, and they hit each other and move away, the bigger ball will move less and the smaller ball will move more in a proportional sense. So the bigger the mass, the less it'll move, and the smaller the mass, the more it'll move. That's what I mean by a symmetrical asymmetry. Another example is, say you throw a ball up in the air and it comes down. Well, really, it's the Earth and the ball that are moving towards a center of mass and energy. It's just that the Earth is so much bigger than the ball, it seems like it's not moving at all. So that's another example. What else do I want to talk about? Another example of this, because I was talking about trying to fill the gap, that's really like a sort of like a Zeno-like paradox for the exchange of energy. Another Zeno-like paradox is for the angle between planets as they move about a center of mass and energy of the solar system. So suppose the angle gets smaller or wider. If it's indefinitely divided, these angles, then change can never occur because it gets indefinitely deferred. For it to go halfway somewhere, it has to get a quarter of the way there, and then you get a quarter of the way there, it has to get an eighth of the way there. So there has to be some sort of fundamental limit for angles or distances. And I like to think that this is the Planck distance, or what they theoretically came up with as the minimum length that could be measurable due to a rearrangement of constants and what they call the uncertainty principle. So in that kind of way of looking at things, there's no such thing as motion. There's really just discrete changes in position that are like teleportations. What else? The other problem with a hidden space-time medium is you've got the hidden space-time medium that's in the image of an ordinary solid or fluid, and it's influencing the planet, which is a solid and fluid. And the second issue is that beyond overlapping direct atomic relations that are being perturbed, nothing within that is actually observable. What I mean by that is that we don't even perceive direct atomic relations, let alone atoms or electrons or protons or nuclei. These are all extrapolated or reconstructed, or energy levels of atoms, or collisions between atoms, or scattering between atoms. These are not things that are observable. They're reconstructions from perturbations in these arrays, or overlapping direct atomic relations that are being perturbed. All detectors are built out of these things, or built out of this. So I'm saying that within these overlapping direct atomic relations it's not anything at all. So all these patterns I call symbolic matter. So it's not actually composed of anything, and that seems weird to people. But if it weren't hollow at the bottom, then it would be indefinitely deferred. That's the other option. But then you'd have another Zeno-like paradox for the transfer of energy, because it would never get anywhere. Because every electron would be composed of something else, then composed of something else, then composed of something else, and energy would just never get out of the electron, for example. What else do I want to talk about related to that? So I'm not really attacking evidence so much as the picture, because they're always trying to convince you of something that's not conceivable, whether it's 11 dimensions or getting rid of gaps, or if you could conceive of an atom. The problem is that electrons are zero-dimensional empirically, and mesons are two-dimensional, or one-dimensional, and baryons, which are three quarks, can only be two-dimensional. And so how can we observe something that's two-dimensional, or something that's zero-dimensional? We can't even conceive of a three-dimensional atom, or a three-dimensional direct atomic, like the stick figures. We can't even imagine that. We can only imagine those three-dimensional coordinate systems embedded within a three-dimensional array. Now, I know you've seen pictures of like direct atomic relations that look like you're looking at it, but it's all done from electron microscope scattering, and it's reconstructed. It's not like they have a lens microscope. What else? What science and theology are doing is they're overgeneralizing the idea of finding or predicting the hidden cause from the external symptoms, which works for like everyday life, like the mechanic or the doctor. They're trying to diagnose, but in those cases, you can find out what the hidden cause is. But in the case of the atom as a hidden cause for the patterns that we observe, or for the gravitational patterns, like inventing a hidden medium, I'm saying that that's an overgeneralization of that idea. Same with the idea of a hidden being. And what's also common about these three cases is that they're inventing concepts, they're repeating concepts, like the idea of a being, the idea of a hidden solid, fluid, or gas, or Wittgenstein. The philosopher Wittgenstein pointed out in the 1920s that it seems like even when people talk about the atom, some people have said the atom is mostly nothing, it's 99% nothing. Well, it's 0% anything. It's not anything. When they're doing that, they're making it seem like it's a macroscopic thing. How do I say that? Wittgenstein put it pretty well. He said they're using solidity and non-solidity in a way to describe the atom, but the atom is supposed to be the explanation for solidity itself. I hope that makes sense. Just like how they're trying to use a hidden form of causation to explain transparent forms of causation. And this idea of repeating concepts in the worldview I've been working on is what conceals reality. Is we cover it up by repeating concepts, and we're reducing concepts in the process too. particularly Einstein's hidden space-time medium, because trying to eliminate gappiness as if like the concept of gappiness were expendable, like it could be taken out. Anyway, let's see, I could talk about a million things. I just don't want to keep this I want to keep this kind of short. So I'll talk about special relativity a little bit. Special relativity is actually inconsistent with relative motion, ironically. Because if you take like the clock experiment, or really what they're measuring is decay rates for whatever radioactive decay. In these clocks that they have a jet and they're flying around the earth and they come back down and they compare it to the decay rates on the ground, and they're slightly perturbed. They're slower. I want to say that calling these two things clocks is a social interpretation. And if relative motion were actually true, which is separate from relativity, then each clock, whether it's moving or not, would be indeterminate. And so the decay rates would have to be indeterminate. I hope that makes any sense. Like, if motion were indeterminate, if the decay rates depended on motion and motion is indeterminate, then the decay rates themselves would have to be indeterminate, if that makes any sense. And also, relative motion is inconsistent with conservation of energy, or that symmetrically asymmetrical events, where they're like this. What they're doing is they're looking at events in isolation. You can compare two things and it looks like motion is indeterminate, but really you have to take into account the entire history of the object, like how it got into motion in the first place. Because if you say it's not moving, but it just got kicked from something over here, you're saying that you're violating that. It's hard for me to explain this, but I think that you can get that picture. Scientists, that's one thing they do. They tend to look at events in isolation. They don't see the cumulatively compounded improbability of events as well. Take like the daily routine of the cell, and you look at all the little events that would have to go exactly a certain way and not any other way. It's really unbelievable. Like, they'll take like the electric law is supposed to be the primary explanation for all these events that are happening in the cell, but this is intended as rigid, meaning opposite charges always attract and like charges always repel. But the behavior of these molecules is so nuanced that could only be the default mode, meaning like there has to be exceptions to that, where it could like, because any kind of contraction or repulsion, like whether it's useful or not, the probability of that is basically zero. So if you compound thousands and thousands of little like contractions and repulsions, they all have to go in one way or rather than another way, in a nuanced way, not in a rigid way. If they were all rigid, then it'd just be zero, pretty much 0 times 0 times 0 times 0 for millions and millions and millions of events, to the point where it's like, it's not even, you shouldn't even be able to have one gene that could be even read off. Nothing should ever go to the right place at the right time. There should be no splicing of DNA and pasting it back together. I mean, it's so absurd, it's hard to even talk about. Some people can get this, but like, it seems like the more you know about biology, it's like the less that you can get it for some reason.